Hello student, today we are going to learn example problem 7.12. Okay, it's from NCERT class 11 physics. Okay, so we are going to do this. If you want more example problem means you can go and see in my playlist. I am given everything. Okay, it's the problem is explaining about the inertia, moment of inertia about the ring. Okay, we have ring. When the ring is rotating using of this. Okay, so inertia at the center of mass is going to be mr square divided by 2. Okay, actually it is not a question, this is given by tabular column. Okay, so they asked what is the inertia, moment of inertia when the when the ring is rotating at the edge of the ring. Okay, so tangential line. Okay, tangential line like this. Okay, here what is the inertia? So this two will be parallel line. I am using as a parallel axis theorem. Okay, so total inertia is equal to inertia at center of mass plus mx square. X is what? Distance between these two. Distance between these two is the radius of the ring. Okay, center of mass, it is mr square divided by 2. Okay, plus it is, what is x? X is r, mr square. So when we are adding this, we will get 3 times of mr square divided by 2. It is called total inertia when the ring is rotating at the tangential line. Okay, the same problem you can do with a different way. If you know only perpendicular line like this, you know this inertia for the ring mr square, inertia at center of the mass. Okay, now you want what is a tangential line for the ring. So same question. Okay, how I can do from here, how I can do. Okay, if suppose you know this value means easily you can calculate. Okay, first I should find what is the inertia at here. Now I am going to use as a perpendicular axis theorem. I will repeat again. I know what is the inertia for this. Okay, from here I am going to calculate what is the inertia at this position. Okay, so before we know this, we found parallel line. Okay, we know this, we found parallel line. In case you don't know this, but you know this line means easily you can calculate. Okay, now I am using perpendicular axis theorem. Total inertia is equal to inertia at z axis. Okay, it is x axis, it is y axis. Inertia at z axis is equal to inertia at x axis plus inertia at y axis. So this two will be equal when x and y. Okay, when the ring is rotating x and y, it look like a sphere. Both inertia will be equal. 2 times of inertia at x axis is equal to I z. Already I told you z value you know. Okay, so it is mr square divided by this 2 I am bringing as a denominator. 2 is equal to inertia at x axis. So now I got here what is the inertia. Inertia at x axis is equal to mr square divided by 2. Okay, now this 2 is a parallel line, distance between these two is the r. Okay, now easily you can calculate what is the tangential line of the inertia. Inertia at tangential line, I am using parallel axis theorem. Okay, inertia at center of mass plus mx square. Inertia at center of mass, now it is center of mass. Okay, for this case this is center of mass, this case this is center of mass. Mr square divided by 2. M, distance between these two parallel lines is going to be the radius, so r square. So if you are adding this 2, 3 mr square is equal to total inertia. Okay, both the way you can find. Okay, both is correct answer. Thank you for watching my video. If you like my channel, please subscribe.